So I would like to call upon Sobhitha, Neelanath.
Great session from Rahul. I guess after that, my responsibility is even more to ensure that you all are not yawning or sleeping. And this is my first time with Test Tribe and Tribe Qonf. First time speaking. Very, very excited to be here and to see you all, and such a full house. Very, very happy for that. And we are going to talk today about intelligent automation continuum. So I hope most of you would have heard about this. Any thoughts that come to your mind when you hear this? Anybody? AI, okay. Other than that, anything else? Okay, fine. So today we are going to talk about, we've all heard about automation. We all do automation, and we also know about AI. AI is almost everywhere now, right? Not just in, in the software space. Everywhere you take, there is AI. So how can AI integrate with automation? We know AI is not automation and automation is not AI. So how can AI integrate with automation, and how can we move forward and make automation more efficient and probably more productive and maybe kind of reduce our manual efforts? That's what we're going to talk about today. Yeah, so the intelligent automation continuum, as you can see here, so there are systems or tools that help us automate, right? The systems do different things. You can see that systems that do are there. So the first part you can see, when I say systems that do, they are usually doing things based on events. They are just collecting data, preparing data, or maybe they are like speech recognition, video recognition, or image recognition. Then we move to the next level, systems that think. Here comes like maybe RPA, predictive APIs, NLP, IT process automation, emotional recognition, etc. So these, what is a shift here when systems that do and systems that think? What is the difference? From an event-driven, they are going to a process-driven state. The systems are more process-driven, not just event-driven in this stage. The third phase is systems that learn. So here you can see deep learning, all the AI-related, AI, ML, IoT, autonomic computing, cognitive computing, all these come in the systems that learn. So when I say systems that learn, they kind of learn from the data. Now, so the first level was events, then process, then we are moving to data. So now everything is data driven, right? We have a lot of stuff going on, lot of data is in place, so it has to be, the systems have to be data driven. So that is how we are moving from this do, think, learn model. So after this do, think, learn, there might be another stage also. Can anyone take a stab at it? What can be that next stage? Sorry, I can't hear. No, I'm looking for a better word. Yeah, evolve is probably closer to what I thought. Adapt, basically, right? So we are looking at automation tools or systems that adapt based on the new changes that come in. Let's say there's a new product, a new software coming in. The tool should adapt for the changes and then, in the runtime, dynamically adapt and make the changes and then get things going, right? So that is what we are going to look at. So in this context, what we are going to look at today are different levels. From the manual, how we go to a fully autonomous or a fully automated testing kind of a stage. It's probably a little hypothetical and a future driven, I would say. And what I would want all of you to think about is, once we discuss all these levels, where do you stand? Where does your process or your automation in your product or in your organization stand now? And how can you move forward in this continuum? So you can see, this is like the AI-driven test autonomy. There are different stages. Level 0 is manual testing. I guess it's very, very minimal now. Not everybody does this. I mean, or it's like only for new features, very minimal manual testing that we do. I mean, it's more for like a waterfall model probably. Level 1 is assisted test automation. Where does this come in? So we are probably executing tests with some automated tools. Level 2 is partial test automation. This kind of, it's the next step to assisted. We are like, more of actions, maybe test generation, a little bit more of actions are automated. Level 3 is integrated automated testing. So this is about, we all know DevOps and continuous testing. Level 4 is intelligent automation testing. Now here we are doing more of smart testing, probably AI is coming into picture, more of AI integration. And the 5th level, or the probably the most efficient level, is the autonomous testing or fully autonomous testing. It's completely AI driven, no human intervention is needed. So we'll be looking at all these levels a little bit more in detail. So I guess this slide doesn't need much of description at all. We all know what we do in manual testing. It's completely human driven. Everything is done by humans, and we also know that it can be very high on cost, time, and the error rates can also be high. I'm not spending much time on this slide. I was also thinking I shouldn't be keeping this slide, but since it's one of the basic levels, I just thought of keeping it. So now we're going to assisted test automation. So here what happens? System comes into place. We have tools which are assisting the humans. We have some automation in place, and some of the probably regression or sanity or many such test cases are automated. But here also the human decision making is very important. Humans make all the decisions. We look at the results, we look at the test results, we decide which test cases need to be automated, and we drive things. Here the productivity is a little better than level 0, obviously. We have better productivity. I mean, things are faster, so obviously the productivity is more. And since it's tool driven, the error rate will be less. And we have tools in place, right? So many tools are there. All the tools are being used here. So I can think of a parallel of, of maybe a car, if you ask me. Nowadays cars come with a lot of options like cruise control, lane keeping assistance, etc. Right? So this stage can be probably considered as a car with all those options. Going to the 3rd stage, partial. This is level 2, partial test automation. So what happens here? Anybody here probably thinks that your current automation process or the maturity is at this level. Any hands up? I want to hear from you what you're doing at this point. No, not clear. Maybe, yeah, please go ahead. Could you share? Can anyone pass on the mic to her?
Hi.
Hi.
So I'm from medical domain. So we have an Android application which interacts with the hardware.
Okay.
So the Android part of it is automated, but the interaction part where it is talking is still manual.
Okay. Okay.
So that is something I thought could be partially or test automated.
Great, great. Thank you. Thank you for sharing that. So yeah, here there is a lot of automation, and not just the execution. There are a lot of insights being generated by the tool. There are even defect detection can be done by the automated tool. So only in case of like complicated scenarios, our intervention, manual or human intervention is needed. And how this helps us with all the insights that have been generated, we can make better informed decisions. We have options, we can analyze those insights which are made and make better decisions. Obviously this increases the efficiency, and since it's tool driven, the coverage, the test coverage will also be much, much higher. So here this can be probably compared to a car with an advanced driver assistance. We have most of the cars, I guess now we have ADAS, right? We look for all those options when we buy cars. Let's move to the 3rd level, the 4th level, which is level 3 basically, integrated test automation. So here the major change what happens is that human plus system, the decision. So till now the first 3 levels what we saw was it was all human driven, all the decisions were, humans were making the decisions. So here what happens, the change is that it is a mix, humans plus system is taking the decision. So the first 3 levels, if you ask me, can be called kind of hugely monitored kind of test phases, right? Because it's too human driven. Now from this stage, what happens is it becomes a little bit working towards non-monitored. So here the humans plus system is taking the calls, and there are integrated automated and manual tests which are working very closely together. Here another thing that comes into picture is we can also monitor the tool performance. So we look at the next level, right? It's not about running tests, getting results, getting reports and insights. We're also looking at how we can monitor the tool performance, how can we reduce the automation time, the test run time, maybe how can we run more tests in the, in a reduced time. So that's what we are looking at here in this particular phase. Of course, defects are, identified in a very earlier phase here because the tools are in place, the time consumption becomes lesser, and the return of investment for the company also becomes better. So this can be probably compared to the conditional automation in the driverless cars. So we are almost moving to that non-monitored phase, right? Self-driving or driverless cars kind of. Level 4, intelligent test automation. So this is again one notch up than the earlier level. Here we are prioritizing the high risk areas also. Apart from whatever was done till this level, the next step is that you're looking at what are the high risk areas. The tool is intelligent enough to understand what are the high risk areas from the failures, and it will give you more insights on that. With this, we can also optimize test coverage. We can decide which areas need more testing, which areas need less testing. And this is a very dynamic testing process in this phase. When I say dynamic testing process, what happens is that if there are failures, sometimes the tool looks for options, maybe more waits, more sync times and all that, right? The system looks for other options. What are some other options that it can take so that the test is not stalled or stopped? We are just thinking of going ahead and trying to ensure that the script runs and then we get the results also. Obviously, we all know about the integration with CI/CD pipelines. I guess most of us would be using that now, right? Either Jenkins or any other tool for the pipelines. So here, the test cycle or the runtime reduces further, and there is more and more quality improvement, because what happens is it frees up a lot of time for us humans, right? We can use our skills for more creative things, more important things, or more innovative things, or how we can take our product quality to the next level. So this can be probably a driverless car which can maybe do a highway driving. I still don't know which driverless car can drive in the Bangalore traffic yet. I mean, I really doubt about that. So this is that stage, and we are now coming to the final stage, which is the fully autonomous testing. This, I know that at present, I guess very few organizations have adopted this, or probably people are still in that phase of adopting this. If you ask me, at my organization, we would be at between level 4 and level 5. We are probably at the beginning of level 5, I would say, sorry, level 4, I would say, not yet at level 5. So this is a very ideal situation wherein there is continuous learning. It's like powered by AI, and everything is done by AI. The test cases are generated. You are looking at the requirements, you are generating the test cases, executing the tests, generating the reports, and then looking at those insights, doing a lot of self-healing. All this is done by AI in the tools. That is where this particular, this autonomous testing phase is. So obviously we have zero touch defect identification and reporting. So this is something I guess most of us in our organization would be working on, I believe. And with the usage of AI algorithms, we can ensure efficiency, accuracy and speed. It will definitely be more. The only thing, the human intervention where here it comes, is when the AI system performance is needed, right? To monitor the AI system performance. You just need to look at the system performance, if there are any glitches, if there is any fine tuning needed. Only in rare cases is what the human intervention is needed. Otherwise, the system runs on its own, self-heals, and then keeps running. So it's like a very ideal situation where most of your tests are running in that stage. So it will be like for a matured product, or at least if it is in a kind of, maybe if you say a maintenance or a sustenance kind of mode, you can definitely use this. If you ask me, that will be very efficient and helpful. But if you are going for a, let's say, a very new product, reaching this level 5 may not be possible, because you have to go through each of the stages and attain that maturity, improve, and then go to the final stage, because this stage cannot be like just reached just like that. Especially for a new product, there will be more and more defects, more and more ambiguities and uncertainties, so that much wouldn't be possible. So this is like, obviously a self-driving car where no intervention is needed, like the Waymo cars probably in US that they have, right? They run as taxis, etc. They can take you anywhere. Everything is driven by the system. They have maps. I mean, you just give the details and the car takes you wherever you want to go, right? Without any problems. It's able to navigate any blockages, reroute itself, do all that and then take you wherever you want, without any intervention from you. You just sit in the car and go. You're not doing anything else, right? So that is where this autonomous testing phase will take us. So this is probably the ideal phase or the perfect thing that we would want to reach to. So that is what in the initial part of the session I told all of you. Probably you should look back and think where your current state of process or the automation is, and then how can you probably improve, have more AI incorporated and reach this particular phase. So we're looking at a little bit of more of aspects about autonomous testing now. So, how do we implement it? What are probably the phases, or what all do we do? Obviously, the first step is defining the test requirements. It's very, very important that we identify which tests we need to automate and which tests we give it to the autonomous testing, right? What kind of test? That prioritization is very important. The initial requirements, build a strong test automation team. Obviously, without an automation team who is, AI aware and AI skilled, this will not be possible. Develop comprehensive test strategies. Like Rahul told in the earlier session, it is very important as testers that we know our product, our domain, what is the business use case or the customer use case of the product, how do the customers use it, and what are the different scenarios, what is the customer configuration or the environments that they use it in. All this is very, very important. Without that, it will be very tough to implement such a autonomous testing strategy. Train and monitor the algorithms, very important piece, right? We should know which, we have so many tools available now, so many, you take it, you kind of know it, you have it everywhere, like you have so many tools. And you should know which one to pick and then how to train. The data is very, very important. How you train and monitor the algorithms is very important. What kind of data you feed into the algorithm model and how you test it is also very important. Choose the right tool. Collaborate with developers. Yeah, this becomes very, very important, I guess, as testers. That is another skill. Rather than getting in loggerheads with developers on the defects, we should work with them and understand what is their design or what is their implementation, how are they planning to implement it, so that we can do a lot of shift left and enable our tools and automation to ensure that the defects are found early. Establish clear metrics and KPIs. Now, how do we measure in autonomous testing? What do we look at? What are some of the metrics that we look at to understand whether our testing is successful or not? Probably some things might be how early in the development stage are we finding the bugs, or how many bugs is our automation finding. These are some of the metrics that we can definitely look at. And what are the probably the script failures, right? Not the product bugs, I'm telling about the script failures. How often does your script fail? All these are different KPIs which we really need to consider. Monitor the test results that we anyways do. Utilize continuous integration, integrate it to the pipeline, run it on your probably first level can be in certain on your dev environment itself, and the next set on your integration environment. And if you use like your staging or prod, then you can run it on your staging environment as well. Evaluate and refine and focus on agility. So agility, as in when I say, I hope all of us know, day by day requirements, even the product requirements, even the tool requirements, everything is changing. How can our approach or the framework probably understand better, be more agile, accommodate new tools, what kind of integration touch points are there, how long does it take to integrate probably a new API into the tool. So all these things are, come under the agility point. Now, so we talked about, what all autonomous testing does and how we can implement it. Is it without any challenges? No, it has its own set of challenges. What can be some of the challenges? Initial investment and return of investment justification. So obviously, this testing needs a lot of AI tools in place, and those tools don't come very easy, right? Everything is licensed. There'll be a lot of initial investment needed to get that, going, and not just the initial investment. To get the results, it will take time. For the whole automation to reach that maturity and get that result, it will take time. Complexity of AI/ML integration. We all know, everybody knows AI, but how much in depth do we know the algorithms that we are going to use? How do we choose the correct algorithm? Very, very important. Maintaining test script stability. This, I guess, not just normal automation itself, we know. The script stability is very important. The maintainability is very, very important. Handling dynamic and complex UIs. Yeah, so the current state of products is that everybody is using across mobiles and web, right? So there are different kind of UIs. There are a lot of new UI complicated technologies coming. So we should be able to handle those. Interpreting the AI generated test results. This is also very, very important. How we look at the test results. What do we derive out of the test results, and how do we feed that learning back into our next cycle? Integration with existing tools and processes. So these are some of the things which probably we need to consider when we implement autonomous testing. Now the benefits, I guess we already talked about. I don't need to talk about it much. It increases the productivity from a tester and a developer perspective, because the tool does everything and we can spend our time in more creative and innovative things. Early bug detection, automated maintenance, shortened development cycle. So today is a world where we have to do a lot of, there's a need for faster time to market. Everybody, especially when you're working on a mobile or a web or let's say an e-com kind of a company, there are weekly releases, right? There is that much of competition that we need to put out the product in the market so soon. So all this faster time to market, all these will be really benefited if we use autonomous testing. Now we're looking at some use cases. Probably we can be used in finance, healthcare, e-commerce, we just discussed that, telecom, and automotive. So automotive and embedded systems, I guess, when the firmware and the hardware and the software integration comes into picture, there is a lot of things which happen, and the firmware updates are very, very important. There will be definitely .1 kind of patches, so many patches going on in firmwares, so for which the autonomous testing will help. For telecom, obviously the 5G, with 5G and more complicated technology in place, there it will help. E-commerce, we know, all of us know the big billion sales by Flipkart or the Amazon. I guess it's happening today, tomorrow, right? The Amazon sale also. So in those, very scaled volume kind of times, these tests will be very important and helpful. In healthcare, to simulate the patient data, the patient records, and all the health-related diagnosis for the patients. Finance, validate the transactions. Of course, we all know the importance of finance right now, right? With the digital payment and so many other options in place, it's very, very important. The credibility of the transactions is very important. So these are some of the use cases where I can think of where we can use the autonomous testing. Now, I look at the future trends. Predictive testing will use historical trends to anticipate failures. So anybody here already uses some level of AI to do any predictive tests? Any predictions? Great. What do you use it for?
We are using some snack.
Okay.
They are keeping the track of executions, previous executions.
Right.
Something else, they are checking the previous results.
They comparing.
They are comparing the previous results,
Right.
and they are trying to self-fill by
Okay.
themselves.
Great, great. Yeah, so that's one thing, no? So one way I guess AI can be used is looking at the failure areas. You can predict what kind of bugs will come or which area will have more bugs coming up in the product. Then obviously we all know no code or low code tools, right? The scriptless tools, which so that it becomes no need of so much of skill. If you understand the product in the domain, and then you can easily use the tools, right? You really need not be like a coding expert. Test coverage metrics, That's very, very important because the test coverage, again, AI can be used looking at the current details. You can know, what more needs to be covered, which area needs more of test coverage. Interoperability standards and real-time feedback loops for the defect resolution time. So I guess this is also very, very important. Sometimes as testers, we all know that we log a bug, report a bug, and then it goes back and forth between the developer and us. We are not sure what is happening. So maybe if AI is intelligent enough to look at the code also and what are the changes that were made in the code, it can definitely suggest, right, this is where the area is a problem area. So that will help the developer also fix the issue sooner. So these are some of the future trends that we are looking at for the autonomous testing. So with that, I come to the end of my session. So as I told, I want to leave all of you with some thoughts on where you stand in this spectrum or in this continuum, where your current automation stands, what steps you can take to get your automation to the next level and make it more efficient. Thank you.
Hi. So my question is, if someone is at maturity level 2 or 3, so, and you've shown the presentation on maturity level 5,
Yes.
so someone should directly reach out for 5 or they should go step by step?
I guess it's better to go step by step, and because reaching that 5 is not that easy, right? It's that level wherein your human intervention is so less, maybe less than 5%, right? So I don't think reaching that level, will be that easy. It takes time, and it's a phased approach which will work for you because you never know what other bottlenecks will come on the way, right? When you're trying that.
Okay, thank you.
Hi, I have a question. So, to reach the level 5, can you suggest like a set of tools that we need to use? So you did mention there are so many tools available.
Right.
So can you give us a combination of tools that we can use for
Right.
the self-driven car example?
Again, I intentionally didn't mention any specific tools. See, we have a lot of, like he told, Functionize. We have Mabel, Testim is there. We have like Sauce Labs, Tosca is there. So many tool options are there. What tool and what algorithm or what model you choose is totally depend on what kind of product you're on. I guess there is no one size fits all. There is no one strategy which can be commonly applied. Okay, tool 1 plus tool 2 plus this model will work fine for you. That doesn't work. So that is where we do the feasibility studies, etc. Right? So once, based on your product, and is it more web oriented, more mobile oriented, how are you doing the test, what kind of tests are being automated, all these will, be very, will be the parameters which you have to check so that you can decide on the tool.
Hi, Naresh
Yeah.
here.
Hi.
So this is again between the developer and the tester, okay? So when there is a defect and so we will have to retest, right? So and there is another part is for the regression testing. So how did you, no matter how autonomous our automation is, okay, if the developer does not provide us the exact root cause analysis and the fix, okay, so the percentage of the success would be not 100% or to the 90% rate. How did you fix this or how did you bridge this gap between so when you have the defect and it is pushed for the testing again?
Yeah, right. So as I told, very important thing is that collaboration between the developers. So when you, while you initially establish your test approach and decide on the tool or decide on what model you want to use, it is better to involve the developers also because you know which are the areas or what are the changes coming in, etc. Right? So once you have that initial buy-in from the developer, it becomes much easier. And when you start, and as Rahul also suggested, your knowledge about the product is very, very important. Not telling each and every line of code you should know, but you should know if something is getting changed, which area or which files are getting changed, right? At least that level of knowledge if you have, you can always suggest things to the developer, right? Sometimes developers also, they are like pressed for time, and that's where all these confusions happen, right? So when you work with them, it becomes a little bit more easier with the RCA and, getting that fixed back.
Maybe a classic example
Yeah, go ahead.
Hi, Shobhita. So I am Supriya, working for Evo Automation. I'm just curious to know, in the complete test life cycle as Salesforce, in which part are you using the AI intelligence, or how it is being derived in perspective of Salesforce?
Yeah, so we have, as such, Salesforce believes a lot in internal tools. So though we look at and do the feasibility checks for a lot of external tools, we try to take in, let's say for example, we evaluated Lambda test. So we knew that there are a lot of gaps with Lambda test from whatever we were looking for our application. So what we do is that feedback loop goes into our own internal tool development team. So we kind of in parallel develop some internal tools which are like more tailored to our needs, which help us make things more easier. So that is where I guess that's the kind of model that we follow. So I guess most of the bigger companies, enterprises follow that because it makes sense. We know what is the architecture, there's the platform level, and what are the different code areas which is going in. So based on that, we develop internally. So of course we take a lot of inspiration from the other tools available in the market, but then we tailor and customize and have internal frameworks for our own applications. Thank you. Yeah. One more question is there.
One more question is for Lee.
Okay.
Salesforce, being a person who handles the Salesforce, who work on the Salesforce project. So now in our company, we are doing a kind of a project called of AI-led testing. So we work for different clients. As you are telling, we use different tools, automation tools. So how can we leverage AI, and in the practice, how can we implement the practices which we learned here? So to go to that 5th level, as you said. So now we are doing the capability building sessions.
So which level are you in now?
We are in 3 or 4.
Okay.
Because we work for different clients.
Okay.
So from the practice, we are in between 3 to 4.
Right. I guess again, that's a very good point that you brought in. When you are working for different clients, obviously the requirements and their demands will be different, right? So going for a base or a common model for all of them may not be feasible. That is where probably wherever that the level 4 that you are in at present may work better for you rather than going to level 5, because the client needs sometimes will be contradictory, and then you may not be able to satisfy everyone, right? So you should also look at all those aspects. That's why I told one size or one kind of approach doesn't fit everyone. It is always based on what you want from the from the automation, what kind of product you have, what is the technology, how are the implementations going on. It's a lot dependent on that. Yeah, thank you.